All right. Well, hello, everybody. And thank you for joining us for this Zero Knowledge community call for NEAR here on DevHub. My name is Maxwell. I'm a DevRel here at DevHub, and I'm excited to get to talk about a few topics in ZK in the community today. Just a few reminders about the format of these community calls. These are sort of just open-ended calls for the community. People can propose agendas, people can come talk about the projects that they're working on or tools that they're improving, or just general things about the community and the developments that they're working on or seeing. And today we've got these two topics. We're talking about the privacy use case on NEAR, and then we have some updates from OPACT, which I believe was formerly known as Hide Your Cache. And with that, I guess I'll just pass it along to Pedro. Are you going to start us off then?
Okay, sounds great. Guys, I don't have a presentation today. It's basically just talking, but I can forward you guys a couple of links after. So regarding OPACT, formerly Hide Your Cache, which went through a rebranding due to some concerns, I would say, regarding what is the message being passed by a service called Hide Your Cache. So our version on NEAR went through the rebranding, and it's still the same smart contracts and everything, but we're running on a now different front end and different address. If you guys try Hide Your Cache, is going to redirect you to OPACT's new website. And we are also finishing a new version of it on Cadena, which is the first topic. And we like to call it an upgrade of the version we have on NEAR. And how does that work? So first things first, it is the same basic concept where you can do anonymous transactions, but there, what we did is you're not limited to a ticket. So like Tornado Cache or former Hide Your Cache and other mixers, where you could do transfers with 1, 10, 100 NEAR, ETH, or USDC. Now you can have it's basically a private wallet where you can have any balance and perform any kind of transfers that you might want to. You have a model based on UTXO, so kind of join them together and burn them in order to build new UTXOs, and that way you can transfer any amount of any asset that you might want to. We also made it available so that you could have private NFTs and do private NFT transfers. It should be going. We already have a version for tests online, but you would have to deploy your own front end, and also there are some upgrades that were necessary on Cadena that we had to. They use PACT, which is their programming language, and we had to update it due to not having basic infrastructure for ZK. So there's still no testnet with those upgrades for us to test it on testnet. Once it is available, I can send you guys, but our code remains open if anyone is interested on seeing the mainly. I think what is cool about it is having the ability to perform those transfers with variable amounts. And now I don't know if you guys have any actually questions regarding it, or if they're like too deep into tech, I might not be able to answer them right now, but I can address it later. If not, I'll talk about the following topics.
Yeah, I'm not sure, but I think we can jump to the ZK ceremonies.
Okay, so now, okay, Phil?
I was just going to ask, just out for industry learnings, you mentioned the fact that, you were kind of rebranding and switching a little bit for, because of concerns about the regulatory environment. Is there something about the design of the system now that mitigates that, or?
Okay, so OPACT, or former Hide Your Cache, we already had a a layer before you use the app where you have to join an allow list. We use HappyOne as a provider. So anyone that tries to interact with the protocol, first what you have to do is join the allow list. And when you join the allow list, we are actually verifying HappyOne if your wallet is listed as a illicit, as involved in any illicit activities. But also, while using the application, let's say you'll perform the hack and really quickly deposit it into OPACT, there is a chance that if your account is listed on HappyOne as an account related with illicit activities, you would be blocklisted and your funds would be locked until, of course, if that happens by mistake, we would talk with HappyOne and address the issue. But this is right now, this is our safety mechanism. So you got a bit, you have the HappyOne part, but you also have a bit of game theory there, where if you're a hacker or whomever it is, you don't want to risk losing your funds. So this is our. But that's what we have at the moment, Phil. We also don't have like large transactions. Our largest ticket value is for 100 NIR or $100, which are almost the same.
Yeah.
Well, unless you're hacking someone for like 2-3 grand, more than that, it's going to be a lot of trouble to move a couple millions.
Yeah.
And also, it's more of a, we like to think of it as a proof of concept rather than a final version of a privacy product that could be used in scale, because there are a lot of regulatory issues that also concern us. And we're based in Brazil, so it's a bit easier. Like, we're not in the US. Regulation here, kind of, there's actually no regulation regarding crypto except for taxes, and taxes they just dropped this week. So we're relatively safe, like developing proofs of concept with ZK products and privacy products here. But at the same time, we know that, I mean, crypto or Web3 is kind of countryless, right? So if we're developing something to be used or mass adopt, we have to have that in mind.
Thank you.
And now, regarding the ceremonies and the proofs, those are two new concepts that we've been studying. We've been getting a lot of feedback. First, I'll talk about the proofs because I think it's more related with the first topic. But we've been getting a lot of feedback, especially from users in places where they have not that great of an access to internet, or maybe their mobile, they're using an app that uses ZK through a mobile device, and they have a lot of trouble building those proofs on a mobile device. At the same time, if we do that, the proof generation on a server, we might be compromising user privacy. So we've been studying a solution using TEE, like trusted execution environments. There's Intel SJX, but there's more specifically Fala network. I don't know if you guys ever heard of Fala, but you can execute verifiable private computation inside of Fala, and also decentralized. You could do that just by using AWS or Azure, but Fala brings also the value of being decentralized. And we're developing now a proof of concept to build those proofs on Fala network. First, we'll actually try on Azure and later on there, so that you kind of break the proof generation barrier. So you have better hardware for your users that might be trying to use it on mobile or don't have access to, as I mentioned, good internet providers or anything like that. So we visualized that from the small user base that we have right now, this is one of the largest issues towards adoption, right? Because unfortunately, there's still a lot of requirement to generate proofs. So that is the next step. We're going towards OPACT as a whole, and We could use it for OPACT tickets on here. We could use it on Cadena. But more than that, anyone can. We really want to build it open source so that anyone can use it for their own ZK product. And the ceremonies, they come in the same way, where we've also had when we built the app, we had to make a choice. We were basically either using Graph16 or Plonk, and Plonk we could reutilize the ceremony that was already used, but Plonk, the proof generation time takes way longer, and that sacrifices UX, and some other times that even blocks some users from using it. Like we had that issue with Hydra Cache, where some users got in contact with us and they said, I have an old Motorola device and I just cannot generate the proof there, and I cannot withdraw my funds. And that's something that we had no idea that we would bump into. So using Graph16 is something that we want to do, but the ceremony is just a huge pain to do because it takes a lot of effort with community and takes a long time. And every time you want to deploy a new version of your app, you have to, with Graph16, which is faster for proof generation, you have to. So that is a great question, because from our perspective, like 5 to 10 seconds is what we've discussed with a couple of players as a good industry standard. But I've talked with the guys from privacy scaling solutions on Ethereum, and their goal is to hit the 5-second mark. 5 seconds for proof generation is good. But I think
sorry
Yeah,
to interrupt the question.
No, go ahead, please.
Yeah. Is this in browser or mobile proof generation, or is this server side optimized?
So we would like to, and then again, this is a goal for the future, but I think 5 seconds for any kind of user would be great. I run a Mac M1 and got decent memory, so it's faster to generate proofs here. But mobile device, that is another story. But we know that there are some users that they don't want to generate the proof anywhere else. They want to do that on their own device. So there are multiple angles that you kind of have to attack here, right? You have we feel like using Graph16 is good because it makes it faster for everyone, but also having the option to generate those proofs on a server, like a private trusted server, it also improves. But for the ceremonies itself, what we're developing a proof of concept right now with Fala Network, which is to generate the ceremony for Graph16 inside of Fala in a TE environment. So we could use actual random numbers from there, but we can have also external inputs, different order of inputs, but to build the ceremony there so that it can be built faster. I won't say that it's safer, but it's also, I'd say that it's in the same level of security as a regular ceremony. But those are the two steps that we're taking towards improving, I would say, user experience as a whole, but not just user experience, but also developer experience. Because if you want to build ceremonies for a ZK app, you could do it way faster if the proof of concept works, which is, it's not ready yet. So I don't have something to bring you guys to show you oh, it's working, or we might have issues here or there. But this is the direction we're heading to, not just looking at the app itself for the final users, but how can we also develop backend stuff to improve the experience as a whole. And those are my updates.
Yeah, thank you so much. From the perspective of proof generation, yeah, you said you use your Mac. Have you tested browser proof generation, or from the Mac itself? Because it quite differs a lot.
Sorry, Anton, would you mind repeating your question?
Yeah.
My neighbor is being a bit loud here.
No worries. Yeah, so you said you have tested like proof generation on your MacBook, and my question was like, is it referring for in-browser proof generation or like on Mac at all?
Oh no, it was in browser proof generation. Like right now, if you use OPACT on here, it's going to generate the proof on your browser. We don't have any server side proof generation. But one thing that we're trying to reproduce right now, and we're not being able to, we're trying to find devices, like especially mobile devices, where we just cannot generate the proof. Because some users said that they just can't generate the proof in any ways. And like I have an iPhone, I tried with the Samsung device, but which runs Android, and I could not not generate the proof. It takes a bit of time, but it generates. But we're kind of stuck, like trying to find some old mobile device from someone in order to actually reproduce the mistake that they're having, the error that they're having.
I think like I haven't any troubles with proof generation in web. I just had like the troubles with the time limit, for example, when your proof, like not your, but when proof generation takes like, I don't know, like more than 10 to 2 minutes or 3 minutes. For example, if it's large proof, the browser can stop this process and like they stop this worker. Like my following question: have you considered like for the desktops, I mean like laptops, have you considered like web GPUs?
No, we have not.
Yeah, because I've seen one team is working on them, trying like to leverage web GPUs for proof generation, because yeah, I have my previous question should be: have you made the parallelization proof generation in parallel, or it's done like in one way?
You mean for OPACT tickets, like what we have
Yeah.
right now, or for the
Yeah.
proof? So for the proof system, it's literally, there's like no code at all. It's just a concept. And for the tickets, it's I might be wrong here because I was not the one hands-on on it, but I think that we don't have anything running on parallel.
Okay.
But I will get
because
back to you with that.
there is like the ways that you just divide the processes, like you pre-process the data, and you can actually you divide the gross 16 proof generation in separate tasks, and you prove them, like run them in parallel, and then you're able like to aggregate them in final. Actually, it's like division of the gross 16 proof generation. Why it's important? Because you're able like to have a separate web workers in browser that will have a dedicated virtual CPUs on the laptop, for example, and they will not share only one like worker.
Okay, yeah, it makes sense. I will get back to you, and I'm also curious to know if you have the name of the projects that you've seen, because maybe I can bring it to my team so that they can look at it. One that
Yeah, well, like I think yeah, let me find, and I'll send here in the group.
Yeah, we've seen that one that is really good is Railgun, or Railway and Railgun. They have really fast proof generation. Not everything is open source there, but we know that they have like different circuits depending on what you're actually trying to do. They have more than a single circuit, so that sometimes you can do things faster using a smaller circuit. But since their code is not all open source, we could not like completely find out, but they have like really good proof generation time.
Well, just also one quick question: what's the cryptography of the inputs to the proof? Is it ECDSA or?
Bill, I'll have to get back to you on that one.
Okay, just curious.
I just dropped the link for DevHub GPUs.
Oh, thank you. I will save it here.
Yeah, but I'm not sure that like on which stage they are now. So I'm not sure whether like they're close to any like demo concept, or it's like just the research. And because it really will depend also not like, I'm not sure whether it will depend on devices, but because the GPUs itself are quite different. I mean, even on the laptops and so on. And that's why I'm not sure how to properly will be utilized.
Yeah, one thing that
Pedro, may I ask a question regarding? You said that the railgun guys have a fast generation proof. Like, what kind of in which environment is it? Like on laptop or on mobile device?
So one of our devs, he tried on mobile device and desktop, and he's the one that brought the feedback that it's really fast to use. I know that it's faster than what we have for OPACT right now, but our proof generation, I think it will take 15 to 30 seconds on desktop. So it's not good at all, or proof generation time. But I specifically haven't tried Railgun or Railway. I've tried a couple of protocols like Hinkle, which is they are on Polygon and BSC. They have a good proof generation time, but they've migrated their smart contract right now. So I haven't tried the new smart contract, only the old one. But as I mentioned, Railway, unfortunately, it's not all open source, so that we can see what's going on there. But with
Can you ping me on Telegram?
Yeah,
Maybe.
I will. But from the Anton, a bit on what you were talking about, the proofs, what we see from users is like for small transactions, people might be doing that through their mobile, but like if you look at Tornado Cash transaction history, like they have the largest amount of transactions are on their 100 Ethereum contract, which is like a huge amount of money. And we assume that people are doing that on a desktop. And if you're transferring 100 ETH, you probably have like a decent computer that can process like any kind of proofs. And it's not something that you're doing like on a daily basis, or at least I assume that people are not just moving 100 ETH here and there like on a daily basis. So it's okay to take more time. But for like small scale applications, like, oh, I don't know, I want to buy a movie ticket. Let's say it's a movie ticket, but it's with a private account, and it costs like $5 to $10, which is a small amount of money compared to the 100 ETH. That is something that people will probably use their mobile devices for, and that is where we see fit for like a proof generating system, not as much for larger transactions. And Mike, I'll try to find you at the group right now.
I already sent you a message in Telegram.
Oh, great.
Yeah, regarding the Tornado, I'm not sure whether even like it's desktop proving. I think it could be also done like on remote desktops, like remote servers and so on, like as automatic like trading bots. So yeah, I think like in general, Tornado currently is not a good example.
Yeah, not at all. Like I think this week or last week there was like another hack, and I think it was on Solana, and it happened and really fast. They already transferred their funds to Tornado Cash. I think it's like a different type of user even that we're looking for. Even though they're like really good use cases, they're still their fair share of unfortunate illicit activities. But one thing that I've been thinking a lot, I don't know if you guys got into this discussion topic with anyone else, but we were asked a lot about Hydra Cache or OPACT and NDC voting, because apparently the users that interacted with OPACT, they were blacklisted from voting on NDC. And we kind of have our view of it. We know, like, we don't even have volume for listed activities, but at the same time, it might favor or not favor a couple of candidates by using Hydra Cache, OPACT to fund new wallets and everything. But what is your guys' view on it?
From my perspective, the private voting should be as a feature, but like from another perspective, I'm not sure whether like users will be willing to pay like for such services. I mean, from the perspective that they're trying like to hide who is voting for whom, it's all time the question where and when to charge users, because it's definitely not the case when they come and pay. It should be some like more complex idea of the value generation. I think Garvid had like some also ideas about the NDC.
Yeah, hi guys. Yeah, I do have some ideas. I'm actually on my way home, so I won't be able to speak too much. But yeah, sorry about that.
Okay, no worries.
Yeah, so me and João, which works with me, he joined a couple of previous calls. We were sketching, just having some ideas about like how to build a private voting system, and we realized that it's definitely not as simple as we thought. I mean, if you only want to have like private voting itself, it's easy, but the second part that we feel like is a big challenge is computing those votes privately, like how do you add up all the votes without showing it to anyone, and only at the end of the voting process you disclose the total amount of votes, and you also prove that the sum is correct. Like, that itself is a big challenge to tackle. There's an article that the guys from Mina wrote about it, but it uses Mina. Like, we really were thinking on how someone could build something like that on Near, and it is not as simple as we thought it would be.
Yeah, is that our blog post about talking using LGML with Snuggle.js?
Yeah, I haven't. You mean the Mina one?
Yeah.
Yeah, I was.
Yeah, it's really, private voting is really complex.
Yeah.
I was going to say something like LGML with Peter, or some sort of Peterson commitment. You can do this. It doesn't even need to be a zero knowledge proof. Well, a Peterson commitment is kind of, but yes.
Yeah, the zero knowledge came in for, I mean, there's two things. One is privacy preserving proof of eligibility to vote, and then I think the other was for proof of correctness of the tally.
Mm.
Yeah, but it is definitely, like, if it was just to hide the votes itself, it's relatively simple. Like what we have with like OPACT right now, it could be used to. But the second part is, but it's a nice challenge to tackle, and I feel like it's probably the next step that NDC will take on voting.
Alio have done a bunch of on-chain voting. They have a repo for how they do it if you want to have a look for it. Or I can try and find it.
Yeah, I would love to.
Okay,
I think we also have a repo with private voting. It's pretty old one. I think we did it like a year and a half ago. But the initial idea was that you basically deposit tokens on a smart contract and provide a private instruction with like option A or option B. And on the execution date, the smart contract transfer your voting to the original voting smart contract. But with the instruction like, is it like option A or option B? So you basically don't need to reinvent the whole voting process. You just did this like just before you have an execution just before the voting ends on the target smart contract.
That sounds like
So if you need, we can find it on our Git. I think it should be public.
Also send a link to the last year's hackathon submission for the private voting. Good
Nice.
yeah, in my opinion. Growth 16, yes.
That's nice. Guys, let me ask you, the first topic with the privacy use cases on your, are we waiting for anyone to join from Zeropool or?
Yeah, I'm not sure.
As far as I understood, they're not joining.
Yeah. So yeah, if we don't have any other topics and nobody wants like to raise hand to talk, I think we are all done, and yeah, and we can end up.
Yeah, voting is like too big of a topic. Maybe it deserves
Definitely need to prepare.
separate.
Yeah.
Yes, attention.
Yeah. Let me ask you guys, will any of you be at NearCon this year, since most of you are in Europe, so it's closer?
Yeah, I'm planning to.
Oh, that's nice.
Probably not, but I would like to. But yeah, family issues.
I'll be on a booth there, so come say hi. We are unveiling some things.
Definitely. Me, João, and Rafael will be joining from Brazil.
Cool.
We went last year and we are like, oh, we got to go back there. So we kind of decided like on a last minute, but we'll be there to chat.
Super
more.
cool, guys.
Okay,
Don,
good.
what project were you with?
Uh,
Because you said you were on a booth, right?
yes.
Which project? Or which?
I work in Pagoda, but
Oh, okay.
we will be unveiling a bunch of stuff I've been working on. So it'll be cool if anyone is interested to come say hi.
Very cool. Yeah, I knew the protocol team had something in the works, but I've only heard like the name. So anyway, I'm excited to see what's been going on. All right. Well, if there's nothing else, I suppose we can wrap up here, right? And
Yep.
Cheers, guys. Yeah, thanks for the community.
Yep. Thank you so much.
all right. Thanks, everybody.
Thank you, everyone.
Bye.
Always nice to see you.
Bye.
Have a good one. Bye-bye.